Welcome to the Trenching and Excavation Safety Training module. This module will cover the following topics: the common dangers associated with trenching and excavation work, the importance of the competent person, the importance of soil type in evaluating excavation and trenching hazards, and the protective systems of sloping, shielding, and shoring. An excavation is any man-made cavity created in the ground by removing earth. A trench is a kind of excavation. It is a narrow channel that is deeper than it is wide. The term trench is typically applied to channels that are less than 15 feet wide at their base. Excavating is one of the most dangerous operations in construction work. There are an average of 70 deaths each year in the U.S. due to excavation accidents, and thousands more injuries. Most of these accidents could be prevented by following simple safety procedures. Even if you are not in charge of overseeing an excavation, you should be familiar with the general hazards of this work. Knowing how to spot potential problems will help keep you and your coworkers safe. Every excavation operation must have what OSHA terms a competent person. The competent person plans and oversees an excavation operation. He or she is able to recognize any existing or potential excavation dangers, as well as any other related dangers, such as confined spaces or hazardous atmospheres. He or she must also have the authority to take appropriate actions to fix any problems that are found. The competent person also inspects the soil and decides what protective equipment will be used. The competent person must be readily available if problems arise or if there are questions about the excavation. All excavation work needs to follow OSHA regulations, even if the work only involves making a small, shallow trench. A trench that's less than 5 feet deep can still cave in and cause serious injuries. In fact, one study reported that 35% of all trenching injuries happened in excavations less than 5 feet deep. Systems to protect workers from cave-ins must always be used, except in these two cases: when the excavation is in solid rock and therefore not at risk of caving in, or when an excavation is less than 5 feet deep and a competent person has determined there is no risk of cave-in. Most excavation fatalities are caused by cave-ins. Preventing cave-ins should be the top safety concern during excavation work. Soil is very heavy, probably heavier than you'd expect. A cubic yard of dirt typically weighs around 2,700 pounds. Being hit by a wall of earth is similar to being hit by a car. Don't make the mistake of thinking that you can spot a potential cave-in before it happens. Soil can cave in suddenly and without warning. A person buried in dirt will suffocate quickly. Even if the victim avoids suffocation, the weight of the soil can break bones and cause crushing injuries. The following sections will discuss the factors that contribute to cave-ins. Most decisions made about trenching and excavations are based on the quality of the soil. Cohesive, solid soil poses less of a danger of caving in than soil that is uncohesive and granular. Determining the type of soil is the responsibility of the competent person. There are 4 primary categories of soil: solid rock, Type A, Type B, and Type C. Solid rock is the most stable of all the soils. There's almost no chance of solid rock caving in. Type A soil is the second most stable soil type. It is made up of cohesive clay-like soil. Type B soil is less cohesive than Type A. It poses a significant danger of cave-in. Type C is a very sandy, granular soil that comes apart very easily. It is the most unstable type of soil. Most trenching will be done in Type B or Type C soil because these are the most common soil types. Water is a major factor in cave-ins. It increases the weight of the soil and also makes it more fluid and likely to shift. Water in an excavation can come from rain, snow, thawing ice, or groundwater. No matter how water gets into the excavation, it is a potential problem. No one can work in an excavation with incoming water or standing water, unless the competent person has taken the presence of the water into account. Methods of protecting against water hazards include special support or shield systems, water removal equipment, and the use of a safety harness and lifeline. Vehicles, such as backhoes, trucks, and cranes, are very heavy and can contribute to the risk of a cave-in. In general, vehicles must be kept away from trenches unless their presence is absolutely necessary. If a vehicle must be in the area, the competent person must be informed. Once in the area, it must always be at least 2 feet from the trench edge. Vibration is a major cause of soil collapse. Vibration can come from large vehicles, from smaller equipment like jackhammers, or from distant industrial work or traffic. If there is even a small chance for soil vibration, it must be taken into account when preparing a trench or excavation. Soil that has been excavated in the past will be looser than undisturbed soil. Extra caution is necessary when working in areas that may have been excavated before. This includes soil around buildings and around utility lines. Loose rock or soil can fall from an excavation face. Workers must be protected from this danger. Protective methods include scaling of the excavation face and installation of protective barricades. Spoil is the earth that is dug out of an excavation. Spoil places extra weight on the ground and can contribute to a cave-in. It also poses another risk because it could fall into an excavation on top of workers. To reduce risks associated with spoil piles, they must be either kept at least 2 feet away from the edge of a trench, or held back by some type of retaining wall or device. There are a number of ways to protect against cave-ins. The 3 main protective systems are sloping, including benching, shielding, and shoring. Sloping involves cutting the wall of a trench back to a lower angle to prevent the soil from caving in. Benching is a type of sloping where steps are cut into the excavation wall. Shielding involves placing protective structures inside trenches to protect workers in the event of a cave-in. Shoring a trench involves using supporting structures that brace the sides of the trench wall and physically prevent a cave-in. Unlike shielding, which protects workers in the event of a cave-in, shoring actually prevents a cave-in from happening. Sloping requirements vary depending on the type of soil. Type C soil, because it is the least stable type, requires a low sloping angle. The maximum allowable slope of Type C soil is 34 degrees. Type B soil has a maximum allowable slope of 45 degrees. Type A soil, being the most stable, has a maximum allowable slope of 53 degrees. Solid rock doesn't require sloping or any protective system because it is not at risk of collapsing. Many excavations will be in earth that has 2 or more layers of different soil types. The 2 soil layers can be sloped separately. For example, an excavation may have a Type B soil layer on top of a Type A soil layer. If there are other factors present, like water or vibration, the competent person must decide if the slope needs to be lower than the maximum allowable slope. When in doubt about the soil type, the soil must be sloped for Type C soil. This will ensure that the sloping is adequate for all soil types. These sloping requirements only apply to excavations less than 20 feet deep. Excavations deeper than 20 feet must be designed by a registered professional engineer. Benching is a type of sloping. Instead of a straight sloping line, benching involves digging out a series of horizontal levels or steps. Similar to the sloping angle, the benching angle must be based on the soil type. There are two types of benching: simple benching and multiple benching. Simple benching has just one step, or ledge, while multiple benching has steps going all the way to the top of the trench. As a general rule, the bottom step must be no more than 4 feet high, measured from the floor of the trench. Shielding refers to structures placed inside the trench that protect workers in the event of a cave-in. A trench shield is usually in the form of a large box-like structure with exterior walls to protect workers. Trench shields are also called trench boxes or mules. They are usually constructed of steel or wood and can be pre-constructed or built on site. A trench shield only protects workers when they are inside the shield. If a worker goes outside the walls, there's no protection from a cave-in. Shoring is a method of supporting the sides of a trench wall to prevent collapse. There are two primary types of shoring: timber shoring and mechanical shoring devices. Most shoring systems have a similar structure. Uprights are vertical planks that line the excavation wall. This lining may be referred to as sheeting when the planks are installed continuously or if a solid sheet of material is used. Wales are the horizontal pieces that run across the uprights. The struts, also called cross braces or spreaders, extend between the trench walls and support the bulk of the load. These struts can be made of wood or of expandable metal braces. Hydraulic and pneumatic shoring offers a few advantages over timber shoring and traditional screw-jack shoring. One advantage is that workers do not have to get into a trench to install pressurized shoring. The hydraulic brace is usually lowered down on a rope and then expanded remotely with a hand pump. These devices are also light enough to be installed by a single worker. Another advantage is that the pressure in hydraulic and pneumatic shoring can be monitored. This ensures even distribution of pressure along the trench line. Hydraulic braces are more widely used than pneumatic braces. This is because pneumatic braces require the presence of an air compressor on site, while hydraulic can be installed using hand pumps. The following are a few safe working procedures for shoring. Braces must be installed as near as possible to 90 degrees in relation to the trench wall. If braces are not installed straight, they will not support their maximum load, and there is a risk of them coming out of position. For maximum safety, all shoring must be installed from the top down. During disassembly, it must be removed from the bottom up. This prevents anyone from being in an area that is not protected by shoring. Shoring components should be released slowly so as to note any potential failure of other system components or potential cave-in. And finally, when removing shoring, the excavation should also be backfilled as the shoring is taken out. This reduces the risk of a cave-in. Trenches 4 feet deep or more must be provided with a fixed structure that will let workers climb out, such as a ladder or ramp. In trenches, Means of access must be spaced so that no more than 25 feet of lateral travel is ever needed to reach the nearest access point. There are several falling hazards associated with excavations. The first is that a worker or pedestrian could fall into an excavation. To guard against this, all excavations must be properly barricaded and marked to prevent people from walking near the open hole. Jumping or stepping across an excavation is not allowed. Approved walkways must be used to cross over an excavation. Walkways must have guardrails if they are 6 feet above lower levels. Upon completion of the excavation work, the excavation should be backfilled as quickly as possible to prevent someone from falling into it. There is also the danger of objects or loads falling onto workers in the excavation. Loads handled by lifting or digging equipment must never be lifted over workers. Hand signals or mechanical signals must be used as required. If necessary, barricades must be set up around the excavation site to keep away unwanted vehicles or foot traffic. Hazardous atmospheres include poisonous atmospheres, oxygen-deficient atmospheres, less than 19.5% oxygen, combustible atmospheres, and any atmosphere that may cause death, illness, or injury to persons exposed to it. One factor leading to hazardous atmospheres in excavations is the fact that some dangerous gases are heavier than air and will accumulate in low areas. If there is any chance that the atmosphere in an excavation could be or become hazardous, the competent person must take appropriate actions. This might include air testing, installing ventilation systems, and requiring workers to wear personal protective equipment. In any location where there may be a hazardous atmosphere, emergency rescue equipment, like respirators and other PPE for rescue personnel, must be made readily available. Underground utilities, such as electric lines, water lines, telephone lines, sewer lines, and gas lines, can pose additional hazards. Before digging can begin, there must be an attempt to contact local utility owners and locate all underground utilities. In the United States, excavators can call 811 from any location to request a utility locating crew to come to the site. Inspections of the excavation site must be completed by the competent person daily and at the beginning of each shift. The competent person must also inspect the excavation whenever any relevant site conditions have changed. Changes that would require a re-inspection include, but are not limited to, weather changes, such as rainstorms, thaws, earthquakes, and snowstorms. When fissures, cracks, sloughing, water seepage, or other changes are noticed, and if there is a change in the spoil pile location or size. If the competent person determines there is an excavation hazard, workers in the excavation must leave immediately. No one may re-enter until the hazard has been eliminated. This module has covered the primary hazards associated with trenching and excavations, including cave-ins, atmospheric hazards, falling into the excavation, and falling loads. Of all the hazards, cave-ins are the most deadly. The soil type is the primary factor in cave-ins, but other factors include water, heavy equipment, spoil piles, and vibrations. The three types of systems that protect against cave-ins are sloping, shielding, and Shoring. Even if you aren't the competent person in charge of an excavation, you should know the dangers associated with this type of work. Always be aware of your surroundings and never take your safety for granted when working in trenches and excavations.